Hello, welcome to episode number 5 of the Device to Cloud series. This is going to be, as I said in with the previous episode, a theory episode, and there's going to be a few more of those theory episodes. There's going to be one about scalability and another one about security, because I'm adding one that I hadn't planned, but that's informed by me going to 2 conferences, one in Düsseldorf and the other one in Berlin. One was the M2M Summit in Düsseldorf, and the other one was the Smart Remote Services Conference in Berlin. And that again made clear the difference that exists between IT and OT, operational technology in the broadest sense. Operational technology means stuff that makes stuff and that builds stuff and that senses stuff, in difference to stuff that just processes information. So IT, let's draw a line here and say IT is whatever is email, document storage, file storage in the broadest sense, CRM, ERP, classic things that are happening in IT. Accounting and all those things are happening in information technology. And then there's operational technology, and that's kind of where the convergence happens right now. This is why people are getting so excited about the Internet of Things, or people are getting excited about M2M, because the operational technology, factory machines, cars, and all those small devices are now starting to get in touch with, starting to connect with the things that are happening on the Internet, which is currently really more an information network than an operational network. So all the excitement is about the convergence of those two spaces. What's interesting is that people who are building things, who are building factoring machines, who are building automation systems, etc., are now just more recently, kind of getting out of their bus systems. I mean, factory automation is driven by field bus systems that are sitting in machines that are operating on sub-millisecond latency, etc., highly optimized. And they're now just popping up in the last several years to go and embrace the Internet as a way to service those machines better and to also go and integrate them. So the IP technology is something that is fairly new compared to what's happening in information technology for the longest time. Because of that, the trend is that in larger companies, the IT department, which has been leveraging that technology for longer, is the one that gets to set the standards. And many companies are, if they're building software, they're building software for information technology purposes. And the IT department, which runs those systems, which runs the infrastructure, typically is oriented towards running that kind of a software. And now, because there are corporate standards that are being set, and they're informed mostly by information technology, that also reflects in the architecture that's being chosen by operational technology in the products that are being built. And a lot of the same themes show up, and a lot of the same solutions show up, because the IT folks are informing and setting the standards for what happens. And that's not necessarily always the best choice. And one thing I'm leaning towards is that the folks who are building product, who are building machines, who are building devices, actually get to choose their own security strategy that is suitable for those things. Otherwise, you get to something like this. So one gentleman at the conference in Berlin was talking about how they do security for their remote service system, where you had a machine, and the machine has computers inside of it. And the way they did this is you have this local subnet that is inside the machine that has a VPN gateway. The VPN gateway connects out to a firewall, and these are all devices that you buy. So there's a VPN device, there's a firewall device. The firewall device is plugged into another VPN gateway, which is sitting in the network of the factory, which is then firewalled again. So these are all things you have to go and buy. And then this connects out from the factory, because the servicing cannot connect into the factory because it is owned by the customer, connects out to a firewall that's hosted by the company, goes to another VPN gateway, and then connects from there to the servicing system firewall, and then connects to another VPN gateway to finally get to the place where the service technician sits, and then from here out creates a secure shell tunnel through to the machine that he wants to service, and that's being triggered here from the factory to go and connect out. It's a solution that's built based on things you can go and assemble, things you can go and buy, but it seems a tad bit excessive. even though it creates certainly something that is fairly secure from a eavesdropping perspective and from a modification perspective, because you're getting in doubt 3 times the same kind of encryption algorithm being overlaid on top of each other, so that data is fairly secure. What it doesn't protect against is unauthorized access, because very often what seems to be even the norm is that the systems in here, the systems in the machine itself, in the factory machine itself, are not further protected. They have fairly open door protocols. If you can establish that kind of connectivity, you basically just connect to a TCP port and you're in. And what happens here is I create a tunnel through this, and I can go and effectively, if I'm sitting here at the seat, I can go and control that machine without further needing permission. Just the fact that I can get there is often enough permission. And as information technology people, the thing what we would expect is that these endpoints here at the client side in that machine are further protected with a layer. That layer is connected to a authorization system that sits here on the client side, and that the technician here would have to have permission granted for a short period of time to go in and work on these endpoints. Alas, that is often not the case. So it's fully reliant on this kind of a link. It's interesting that people think of this as magic. They're basically just buying security, and that's not necessarily yielding a sound security model. And let me go and break this down a bit in terms of layers. And also, VPN is equals security for a lot of people, specifically in this space, and that's not necessarily the truth. So let's see where the security actually sits. So I'm going to break this down, and this is the audience that I have in mind here is folks who are building the machines, and not necessarily people who have experience in IT for a decade or more. So let's go and take the magic away. First of all, let's talk about this link and how that link happens. And I'm going to take this fairly excessive amount of gear that someone has sold to someone else away. And let's think about how a machine here can go and talk to another machine, assuming that this server here is listening for traffic, and then there's obviously also a case to be made for cloud-assisted connectivity, but I'm going to ignore that for the moment. So I want to go and create this link. This is happening over the internet. So there's multiple parts that are happening here. So first of all, there's a router at the edge here. Let's go and use a different color, and let's go use black. So there's a network, and there's a router at the edge here. This was the VPN gateway that the device was plugged into. And then, of course, there's multiple of those routers on the way in the infrastructure until it kind of gets here. This is the public IP address of the server, and then it goes in here. So this thing will be an IP, and this will be a NAT typically, network address translation, or actually for inbound connectivity, it's going to be some port mapping onto the server that actually sits here. So there's multiple things that are happening. First of all, this server needs to be able to get to its gateway, and that happens through some physical means. Either there's a radio signal going or there's a wire signal going, and that needs to be transmitted. And then also there's wires that are running between all these different routers. Or this also might happen over radio, this might happen over some kind of a satellite link in extreme cases. But there's something where that happens. That is a physical, there's some physical transport mechanism, and the logical part of this is a link layer. A link layer basically says there's a link from here to here, from here to here, from here to here, and that transports frames. Then there's a notion of this guy, so this server here saying, I want to get this data to this place, and that needs to be that happens by ways of an address. And I'm going to just pick a number here, 1.1.1.1. That's certainly owned by someone. That's an internet address, IPv4. IPv6 address would be a little bit more complicated. So this is an address. That address is encoded somewhere in some way in these routers, which know where 1.1 the general direction and sends it in that general direction. That whole notion of routing is the network layer. And then there's a notion that if I go and transfer data from here to here, I need to be sure that all the packets that are routed arrived all together in the same order if I want to form a stream, or in the other case, if I just want to send little datagrams, frames of data, and route them, then they also need to kind of be addressable, and there needs to be data attached to them, like a TTL, a time to live, so that urgent packets don't show up later, or they don't show up at all. They're eaten by the network if they're no longer important. So that level is the transport level. And transport level, for instance, at the TCP level, it means that I start sending a bit of data that's separated out into little data chunks, 1, 2, 3, 4. And I send them over here, and as they arrive, they're being put back into a buffer. 1, 2, 3, 4. There's a certain size of that window. And once they all arrive, then I'm going to send an ACK back. And if they don't all arrive, then the other party is going to go and resend them to make sure that that the stream is consistent. That's all that management happens at the transport layer. So there's link layer to go from here to here. There's network layer to go from here to here. And then there's transport, which kind of gives higher quality services. There's examples of that. So at the link layer, the logic here is, for instance, Ethernet. At the network layer, it's, for instance, IP, v4, v6. And at the transport layer, there's stuff like TCP and UDP and other protocols. From a security perspective, because we're talking about security here, there's various ways to go and protect those things. First of all, Ethernet, the simplest model of protection here is to go and take your Ethernet hub, if it's a wired hub, and put that into a cabinet and lock that cabinet. Physical access security. You can't get onto into wired Ethernet unless you have access to the cables. But then if you lock it into a cabinet, you would also have to go and lock all the cables away, so that's and all the plugs away. So physical security in terms of Ethernet is typically by physical access control. The equivalent of physical access control to that subnet, so to that space here, this is what Ethernet covers. The radio equivalent to that are mechanisms like WEP, which is no longer good, which we used to use for Wi-Fi, which is still state-of-the-art for Zigbee. And WPA2, for instance, for wireless, is the current way of how you can go and prove that you're authorized to go and participate in that link layer network, and also how your link gets isolated from everybody else. So that gives you a secure cable into that network. At the IP layer, there is a way to go and establish a link between two parties, like this here, this relationship, and go and encrypt all the packets. That mechanism is called IPsec. And at the transport layer, so within UDP or within TCP, there are things like DTLS or TLS. TLS running over. This works for datagrams, and this is for streams. So this is a foundation, kind of a technology foundation for this. Here, this is assuming that you have a TCP connection, and this is working also with UDP, but it has the same foundation. And then there's, of course, also something like SSH. These two are UDP based. This one, are TCP based, and this one is UDP based. What does VPN do? Well, VPN is picking one of these protocols and then layers on top a virtualization of effectively a network card. So VPN per se is not a security mechanism at all. VPN is leveraging one of these security tunneling mechanisms to go and create a secure link. And in an extreme case, if you take the layer 2 tunneling protocol, L2TP, you can actually make a VPN without having any security at all. You can use plain text and basically just go and do an address translation, addressing trick, where you use effectively the VPN tunnel to go and just do addressing tricks to link these two networks. So what happens in these? What happens with a VPN in relationship to this? Well, if I create if these terminal routers here are VPNs, are VPN gateways, what they do is, as you are creating this VPN link, this VPN on top of them, on top of this layer, on top of the transport layer, and in the extreme case on top of the network layer if you use IPsec, then you are creating here a virtual network card. So you already have a network card, but now you're creating a new one. You're creating a new one that's kind of uninitialized. And if you're the client, what you will do is if you show up in an IP network, if you're using, this works with any network because it happens at the link layer. The VPN creates a new network card at the link layer. If you are in an IP network, what you do is you say, oh, I don't know who I am, here's my MAC address, but I don't have an IP address. You go and ask the DHCP server. So what happens here is that guy, so this, let's say it's this server, that goes and says, who's the DHCP server in here? What happens is with VPN is that it takes this guy, and it takes those two networks and joins them, merges them together into one network. So now, by ways of that VPN tunnel, you now get one space where all of these computers and all of these computers are in one link layer network. You see where the risk of that might be because if one of those, if a machine here or a machine here is infected with any kind of illness, they have now complete liberty to go and exchange those illnesses with each other, which is probably not a good idea. So if you can't trust this, or if you can't, if this party can't trust this, building a VPN link, it's probably not the best idea. But let's continue. So this guy now says, who's the DHCP server here? And since it's on network, the DHCP server that sits over here will say, I'm the boss. Now you are getting an IP address. Mind that this guy already has an IP address for this underlying link that we're using. So there's one layer, now we're adding a second layer. And on that second layer, on that virtual network, hence the name, this guy is now getting an address from this guy, which is the DHCP server. And because the DHCP server is really nice, what also happens kind of in that same handshake is that that address gets registered, might get registered in DNS at the same time, or this guy might go and register in DNS. So now the machine actually can also get a name, becomes addressable in here, or there's some kind of discovery mechanism going on, or some kind of way, some other kind of way how this machine will go and register here with a management system. And now you have a way to go and communicate from here to here, where the security for this is provided by IPsec, or by TLS, or by DTLS, or by SSH. The difference in choices that you make are depending on what kind of latency requirements, for instance, you have, and whether you're actually doing UDP traffic, because that actually matters. So, for instance, if you're using TLS, so an SSL tunnel, or you're using SSH, then your tunnel here is going to be TCP, and it's also going to be throttled. If I can't get the data, if I can't get all the data, then I'm going to make this slower, this link, and this quality control, flow control happening here. And if I want to send UDP data, then that UDP data is now going to flow in the TCP tunnel, and it's going to lose some of the characteristics of UDP. For instance, it's going to have higher latency. So if you need that, you need to have something that deals with datagrams. So IPsec and DTLS are better for that, and so therefore the general practice, today's best practice for building VPNs is typically based on IPsec, but IPsec also is a big hurdle because that needs to be sitting inside of the TCP stack. So for tiny devices, it's a bit of a big leap still, because not all embedded TCP stacks are supporting IPsec out of the box, because IPsec has a requirement, similar requirements to what TLS has in terms of support for certificates, exchange of certificates, etc., negotiation, and that makes the IPsec handshake a little bit heavyweight. So let's summarize this. VPN does not add security. VPN is a way to virtualize the network over here and virtualize the network here and to make a single network space. If anything, using a VPN per se removes the isolation between this network and that network. So it arguably makes an environment less secure by adding computers you might not know about into another network. So you must trust both. The security of VPN is established by using one of the protocols listed here, which are also used in exactly the same way, with exactly the same security characteristics, if you leave this whole VPN magic completely out of the picture. So if you were only, we leave all this out. Let's start again. So if we're getting all this, this magic of network virtualization and addressing and all those things, and say, okay, so we're going to have a firewall here, NAT firewall. We're going to take this server and we're going to pull this out onto the edge. I'm going to give it a port, 8888, as a first approximation on some public IP address. And now the software in here doesn't do any of the magic in terms of VPN. It doesn't establish any tunnel. It doesn't allow that. It simply goes and makes an outbound connection and does that using TLS. Or does that using IPsec. But let's go and stick to TLS. What you now get is the exact same security properties as you get with VPN, because it's the same algorithm, it's the same handshake, because the handshaking for VPN is done using TLS. That's how this tunnel is secured. The VPN part simply adds the magic in terms of networking at the edges, but it doesn't really add security. So this secure tunnel, a simple socket, is just as secure as the VPN tunnel is. It just doesn't, it's not as invasive into this network and this network, and it keeps them isolated. There's now no talk at the link layer. There's only talk up here at the transport layer that the application can talk to. One single endpoint exposed, not the entire network exposed. So this is arguably a slimmer and more secure way, and it also doesn't add all the fear of having a secure link instead of a secure link instead of a secure link, and it also is in the end more efficient. So VPN per se is a great technology if you really want to fuse two networks together. If you really want to be a full participant, if you have a trusted computer and that trusted computer now joins a network, as I do personally with, for instance, the Microsoft network. I get on the Microsoft network because I use all the services. I talk to many machines. My machine is fully patched up completely. And there's a requirement that I actually go and install all the security patches that are available before I join that network, because it's a low-level integration. So that's something that is really, really important in terms of creating that link. Now, with that, the threat that we've addressed is snooping, is eavesdropping, so that nobody can see what's going on the wire here, and that is that, and eavesdropping, and then also modification. With that handshake, with the TLS handshake, and the same applies to IPsec, what happens is that all this traffic, all the data that goes in here, gets signed. So blocks of data gets digitally signed, and then all of the signature plus the data then gets encrypted, so you can't see it, and you can also go and falsify data as it goes across the wire. As we do that handshake, as that happens, authentication takes place. A minimal amount of authentication takes place here. And that's also very similar to what happens in VPN. And that is, first, we establish who the server is. So there's a notion of server authentication, and that's happening through the certificate. That's the next piece of magic that's being used. We use certificates, and therefore we're secure. What are certificates? Certificates are little files, and those files are special because they contain a private key. So there's a public version, obviously, there's a private version of this, and you go and install that certificate with that private key into the server. The server with that signs some data, sends you that data, and you have the public key, and you can see based on that signature, because we're verifying that signature, that the server is authentic. If you have client-side certs, so you can also go into client auth using certificates, where the server is now in possession of a certificate, your public key, and so you go and sign a piece of data, and you send that over here with the client, with the private key you have here, and then the server can know this. This is something that happens intrinsically all in the TLS handshake. Typically, however, because of the significant management load that is on the server with client certificates, only typically the server is authenticated. So the client then creates a connection, makes sure it talks to the right server so it doesn't volunteer data to the server that it doesn't want. And then further authentication steps happen, so where the client basically proves who he is, then typically happens through the TLS tunnel, where this service then has a different endpoint. And that's something that I'm going to talk about in the next episode, because I don't want to talk about all these different mechanisms, the tokens and federation and all those things all in one go, to not overwhelm you. But authentication, basic authentication already happens at the transport level, and it's also important so that the client doesn't volunteer secrets, doesn't volunteer information to a server that it can't trust. But all of those things already are baked into, for instance, TLS are also baked into IPsec, are also baked into the basic protocol suites, and there's also nothing that VPN fundamentally adds. So, and certificates, once you have establish the authenticity, and once you have used these public-private key pairs to exchange a so-called session key. So what's happening is with this handshake, as those guys start talking to each other, they are establishing a session key at both ends. This is so-called Diffie-Hellman exchange. Now both are owning the same key, and as soon as payload traffic starts, the certificate, the magic, is completely out of the picture, because then all the data is encrypted symmetrically using a symmetric algorithm using this exchange session key. So those magic certificates are being used to establish the identity of the server, typically, sometimes the identity of the client, and then are used as the basis for the exchange of the session key. And once the session key is established, so once we are starting to exchange payloads, then the certificates are already out of the picture. They're just really there for the handshake and for the authentication piece. So much as a kind of dissemination of, or a separation of what really establishes security, and that is these basic protocols up to the transport level that are establishing that a secure connection against eavesdropping and modification, and also to establish the identity of the server and sometimes also of the client. And that VPN is really just an addition to this, which fuses to networks, which is very often, and especially in cases where you're making machines talk that are not necessarily trustworthy to each other, that it is not necessarily from a security perspective the best way to go and fuse those two networks. But that point-to-point tunnels, application-to-application tunnels, are usually the better choice. And in the next episode, I'm going to go and talk about the authentication options and what we have at the application level for options, and also what we have in terms of options for probably not using TLS, because TLS is also a fairly heavy protocol. Thank you for your attention, and I hope I see you back in the next episode.